Everyone, I'm Takahito Unekawa for the Mitsubishi Heavy Industry Engineering. I would like to thank you for giving us the chance to speak about MHI CO2 capture technology. In order to achieve the carbon neutral in 2050, anthropogenic CO2 emission must be reduced. However, even after such efforts, we expect around 4.3 to 13 gigatons of CO2 emission to remain. To capture this remaining CO2, 100 to 300 times the capacity is needed. In 2015, CO2 capture will operate in wide range of sectors, including industries, fuel production, including the blue fuel production, power generation, and others, aviation, transportation, and so on. This slide shows the concept of the CO2 ecosystem, which connected the CO2 emission to CO2 storage and utilization. We believe CO2 ecosystem can accelerate carbon neutral. A good example is UK government's CCUS hubs and clusters. Such a concept stimulates the CO2 capture market, and CO2 capture process application is being expanded various CO2 emissions such as cement plant and steel plant. MHI working for the CO2 capture since 1990s, and we currently receive more inquiries for CO2 capture plan than ever before. In addition to the CO2 capture from the fossil fuel-fired flue gas, MHI working for the R&D and demonstration test for negative CO2 emissions such as capturing CO2 from the waste-to-energy plant and biomass plant, direct air capture. MHI is suggesting the CCUS digital platform for CO2 value chain building, and it can realize the data transparency and business flexibility for tracing and trading of CO2. MHI investing on innovative startup for accelerating R&D of techs and products. One example of innovative company which MHI invested in is Infinium, which has technology to produce electrofuels from the green hydrogen and CO2. I would like to introduce MHI CO2 capture plant technology, which is called KMCDR process. This technology has been jointly developed with Kansai Electric for 3 decades. It is an amine-based technology and can absorb the CO2 from combustion gas at more than 95%. KMCDR process has 6 main features. The first feature is high-performing proprietary amine solvent, case and case 21, which has a high CO2 capacity, low degradation character, and low regeneration energy requirement. Second feature is the amine emission reduction system, which can reduce the VOC emission and amine emission. The third feature is a heat integration system, which can reduce the steam consumption. The fourth feature is amine purification system, which can filtrate unwanted impurity. The fifth feature is automatic load adjustment control, which can adjust the operating parameters automatically to optimize plant performance. The last feature is proven tower design, which can ensure reliable CO2 absorption performance for large scale. This slide shows MHI CO2 capture development progress. MHI CO2 capture development activities began in 1990. 2-ton per day pilot plant was started in 1991 at KEPCO Nanko Power Station. Case 1 and KMCDR process was developed in 1994. The first commercial plant was started in Malaysia in 1999. 1 ton per day coal pilot test was started at Hiroshima R&D Center in 2002. US Plant Valley 500 ton per day demonstration project was conducted from 2011 to 2014. Case 21 and advanced KMCDR process was demonstrated at TCM in 2021. This slide shows the worldwide commercial experience. 14 plants under operation and 3 plants under construction. This slide shows CO2 application for each project. Major application is urea production. CO2 capture plants were added to fertilizer plants and capture from the flue gas of the reformers. The recovered CO2 was synthesized with ammonia and converted to urea. For 2016 CO2 capture project, CO2 applied for CO2 EOR in USA. Therefore, CO2 capacity became about 10 times. This slide shows the outline of the world's largest CO2 capture plant. This project was supported by DOE grant program, CCPI Round 3, and Japanese government finance. Plant location, NRGW Parish Power Plant, which is 40 minutes drive from the downtown of Houston. Project owner were Petronova, which is a partnership between NRG Energy and JX Nippon Oil Gas. The plant capacity 4,774 tons per day, which is equivalent to 240 megawatt. The recovered CO2 is sent to the oil reservoir, which is located 440 kilometers far from the plant. Petronol project was reported on budget on schedule. This project was awarded Plant of the Year by Power Magazine. This slide shows the scale-up progress for the KMCDR process. In order to achieve the 5,000 ton per day commercial plant, MHI had conducted the scale-up of the CO2 capture plant in the step-by-step, 1 ton per day, 10 ton per day, 500 ton per day, which is the accumulation of the technologies and experience. In addition, DOE evaluated KMCDR process TRL, the technology readiness level 9, which means the technology available for wide-scale market use. Drax and MHI have agreed a long-term contract for use of the MHI carbon capture technology at Drax BEX project. This project will become the world's largest carbon capture project, which has more than 5 times capacity of the Petronova. This project will be world's first negative emission project. This project will be UK's first carbon capture project at scale. MHI Engineering has entered into the agreement with the Technology Center Mongstad, TCM, to test its proprietary solvent for capturing CO2 at the amine plant located in Mongstad, Norway. The test campaign was completed in October 2021. Case 21 solvent jointly developed with KEPCO achieve up to the 99.8% flue gas carbon capture rate. TCM offers world's largest and most flexible facility and expertise. MHI aims to expand its carbon capture business in UK and Europe. We are further expanding the number of the applications for the CO2 capture based on our core technology. As a leading company in CO2 capture, we offer the wide range of CO2 capture technologies. For next decade project in Texas of USA, CO2 capture plant will be installed for the energy plant to capture from the exhausted gas from gas turbine for refrigerators. This LNG project is expanded to greenest LNG project in the world. MHI America branch is awarded process design package. For Lehigh Cement, MHI conducted feasibility study for capturing CO2 from the flue gas of the kiln in the cement plant. For K-Line project, the world's first verification of on-board CO2 capture was conducted during the actual voyage. MHI currently designing the tailor-made CO2 capture plant for the large-scale CO2 emission, such as gas-fired power, coal-fired power, and chemical plant. In the future, our product line should be expanded to standardized and modularized CO2 capture plant in order to increase the production number and reduce the cost of medium and small-scale capture plant. The current standardized and modularized CO2 capture plant lineup is from 0.3 ton per day to 200 ton per day, 5 capacity. All product line will be ready by 2023. MHI proceeding the demonstration test with various partners. MHI installed the mobile CO2 capture unit in the vessel and conducted the demonstration test with Kawasaki Kisen shipping program. MHI going to install the zero-point mobile CO2 capture unit in cement plant and do the demonstration test with Tokuyama cement producer. MHI also will install the mobile unit in the Yokohama City waste-to-energy plant for the demonstration test. CO2 capture as a service, in addition to the automatic operation and remote monitoring service, will be started from 2024 in order to make it easier for many companies to introduce CO2 capture plant. MHI Group has a portfolio of the technology essential for the CCUS, including the CO2 capture, transportation, and compression. We aim to further expand our business in the field of the large CO2 carriers and CO2 compression, which will become necessary as the volume of the CO2 increase. We are contributing to the establishment of the robust value chain by offering broad CCUS related technology. Thank you very much.